Chapter 1, Exercise 17. Hence, use properties of the norm and the inner product in RK, definition 136 and theorem 137. Solution. Using properties of the norm and the inner product in RK, we obtain absolute value x plus y squared plus absolute value x minus y squared equals x plus y dot product x plus y plus x minus y dot product x minus y equals x dot x and x dot y and y dot x and y dot y and x dot x minus x dot y minus y dot x plus y dot y equals 2 absolute value x squared plus 2 absolute value y squared. Geometric interpretation of the proved identity is that in any parallelogram, the sum of the squares of lengths of its diagonals coincides with the sum of squares of lengths of its sides. Comments. The proved identity is known as a parallelogram law. A function x maps to norm x on a linear space is called a norm if it satisfies properties a, b, c, and e of theorem 137. It may not be defined through an inner product like it is done in definition 136. For general norms, the parallelogram law may fail. For example, consider R2 with the norm x equals absolute value x1 plus absolute value x2. Let x equal 1, 0, y equals 0, 1. Then, norm x equals norm y equals 1. Norm x plus y equals norm x minus y equals 2. Since 4 plus 4 greater than 2 times 1 plus 1, the parallelogram law fails for this norm. Thanks for watching.